Okay, we're going to start learning a way today to organize our code, especially when it comes to classes, a little bit differently than we have been doing. So this material is meant to be covered in the class, but it's always a little bit difficult to find the proper time to cover this material. So I decided to make a video, given how much we've got to cover in class. I decided to make a video to save us some time in the classroom setting to focus on not more important things, but more difficult to understand things. So this is really just a procedural change, and there are a couple of different things that you need to be aware of moving forward. So follow along with me here, and then you can reference this video as you have questions. All right, so let's go back. Let's try and motivate what we're doing here. Possibly, I wasn't there for most of you, but possibly in 155, when you were first introduced to this notion of global functions. So I have a file open here that has two global functions, one called foo and one called bar. And obviously these global functions don't really do anything. This is not a real program. I mean, it will run and compile, but it's not meant to do much. It has no output, in fact. Well, maybe a little bit of output. And then it has a main function that calls those functions. So one way to organize our thinking about this is to combine, as I have done here, the function declaration, which is kind of up here, and the function implementation into one unit. All right. And if we do that, then we have to put the entire thing above main, right? So this will compile. Let's try it. Okay, compile without warnings, and then it runs. Okay, great. But very quickly, what we instructed you to do was to begin to separate what would be your function declarations from where we want you to put your function implementations or function definitions. Okay, and this is not new to you. You've seen this before. So what we do is we simply put a semicolon here, and we put a semicolon here. Okay, and we can copy these down. I'm going to put that down there for when we come back to it in just a second. Obviously, that's not right as it stands right now, but that's fine. We're going to morph these into what we want to see. Okay, and of course, we could just write this the right way to begin with, but we haven't. I wanted to show you this transformation just so you could remember. Okay, so here's foo, and then function declarations. At least in 255 in my class, we've gotten in the habit of not giving these variable names at this time. Right, so there you go. Function declarations / aka function prototypes are now at the top of main, and then we go down here, and here are our function implementations. Okay, just like that. Right. So the function implementations are down below main. They're kind of separated away from the function declarations, which have to be before main, and nothing changes when we compile this. Run it. Still works just as well. And this is our preferred way. This is our preferred way to write global functions. Okay, separating the declaration from the implementation. All right. So since then, we have learned about classes. So here's a simple main function. It has no global functions. We're not talking about global functions right now, but you'll see that it includes a file called datarecord.h. Oh, and here's datarecord.h, and it has declared inside of it a class called datarecord with a private section and a handful of private attributes, and a public section with a constructor, a parameterless constructor, a parametric constructor, a constructor that takes parameters, and a function called setDate and one called setFormat. And it looks like setDate is doing some validation in here, and setFormat not doing any validation, just updating the format attribute. Okay. All right. And so and we're gonna save. I made a change. I made a spacing change on this one, so you can see this little asterisk inside code blocks, which is the IDE that I'm using. So asterisk indicates that this hasn't been saved. When I compile it, it'll still compile because that change didn't matter. But notice it still didn't get saved. So if I want to save changes, and some of you have seen this, if I want to compile based on changes I've made to the .h file, I first need to save the .h file and then go back over to main and compile. Okay, and it compiles fine. And what happens if I try to compile this file? Well, it tells me no target in no project, compiler unknown. It's not gonna update anything. So I need to be on this file in order for it to actually compile and give me 0 warnings, 0 errors, the .cpp file. All right, so this is not new to you. This is how we've been doing it for the last week or two. So let's run this. Okay, there's no output here because this, again, is just a toy program, just an example. And so it doesn't do anything. It literally has no output. But you can see it compiles and runs without error. Okay, but notice for our methods, we are once again in that early sort of setting where the entirety of both the method declaration, its prototype, and the implementation are in the same place. Okay, so from now on, project 3 requires this. The in-class exercises that we're going to start to do are going to start to require this. From now on, we're going to be required to separate the method declaration from the method implementation, just as we did for our global functions. Now, because this is in a class, the way we're going to do that is slightly different. Okay, what we're going to do is we're going to create an entire new file, just an empty file, and let's save this in the same folder. Okay, I'm going to navigate there. Let's save this in the same folder where our data record.h and our main.cpp are. Okay, let's see. I need to shrink this down so I can actually see it. Okay, and we're going to call it methods.cpp. Yes, that's right. Methods.cpp. So we're going to have, and it could be called anything. The name of the file could be anything, but it needs to be a .cpp file. So when we're done with this, we'll be in the uncomfortable and unusual position, for us anyway, of having multiple CPP files. Okay, but that is a thing that we're going to be okay with because of how we're going to handle this in just a second. Okay, so let's do methods.cpp. All right, so now I've got a blank file called methods.cpp. This is the file, okay, this is the file where we are going to place our function method implementations. Okay, so in order to do that, I've got to do pound include data record.h. Right? And I'm also going to have all the same. I'm just going to do this as well, just to make sure everything's working as it should be. But that you're familiar with. But this is include data record.h. So not only does main.cpp include data record.h, but also this new file called methods.cpp includes data record.h. Now, this file, which I've called main.cpp, is the only file that has a main function in it, right? The simple rule in C++ is that there must be one and only one main function. There can only be one main function because that is where execution both begins and where it ultimately terminates when the program is finished, right? So there can still only be one main.cpp. Over here in methods.cpp, there is not going to be a main function. There is not going to be a main function. Instead, we are going to put the function implementations, or definitions if you prefer, that we had over here. We're going to put them over here. Now, we're not done yet. There's a couple of new things we have to do, but I'm going to show you the pattern for converting from our old way that we're not going to do anymore to our new way that we are going to use moving forward. Okay, so I'm going to take just a second to get this tabbing lined up right, because you know me, I'm a big guy Big in terms of getting the tabbing correct. And of course, if you just write this in this fashion the first time, you don't have to worry about manipulating this over to what it's supposed to look like. So in other words, if you separate your function implementation from your function declaration to begin with, you don't have to worry about doing all this, getting all this tabbing straight. And that's something that doing it this way from the start is something that we're going to encourage from now on. Okay, and again, not quite done yet. That was just getting the tabbing straightened out. We'll come back over to methods.cpp to get this worked out in just a second. Let's go back over to datarecord.h and observe how simplifying this is for our class declarations. Okay, I'm simply going to put a semicolon right there. That looks familiar. That's exactly what I did, right? When I did this for global functions. I don't need these names anymore. Variable names or the parameter names. I don't need those anymore. I'm just going to put a semicolon right here. Get rid of that. Put one right there. Don't need these names either. I just need to know that there's going to be 3 integers that get passed to this function called setDate. Get rid of this because I'm not going to put my implementation in with the class anymore, and it looks like I accidentally deleted one of those. Okay, and I'm going to get rid of this parameter name, put a semicolon here, get rid of this. And this is the entirety of my class statement, right? This is the entirety of my class, the class that I've written called data record. It is literally just the list of private attributes and only the prototypes for the list of methods, public methods, including the 2 constructors that I want to have for this class. This simplifies very much our design process. We get to see this as a design document now for our data record class. Okay, it is literally a blueprint of what our data record class is going to be. Of course, somewhere we have to have those implementations that we just got rid of. We're going to have them over here. In fact, we already do have them over here. Okay, but since they are outside of the data record, okay, and since we don't want the compiler is going to be confused about whether or not are we trying to define a new function called the data record function that doesn't accept any parameters? Are we trying to define a new global function called setDate that accepts these things and returns nothing, has a void return type? Is this are these global functions or what? Simply looking at what we have here, the compiler won't be able to tell. So we have to expressly tell the compiler, no, this is a part of the data record class. So this is a syntax we haven't used before, okay? But when you are separating your method implementations into a different file, you not only need at the top of it the prototype of that method, in this case it's the parameterless constructor, but you also need to say the name of the class that this method is part of, and then give it the colon, okay? Tell it it's the data record, this is in the data record scope. Give it the colon, and then give it the name. And then you can list, the body of that function. And we're going to do this. We're going to do this for all of these data record. Oops. Okay. And you can see IntelliSense there is popping up to try and help me out. I don't need it though. Okay. Data record. Okay. And data record. And I have done this, trying to do this live for you, but I've actually forgotten something. So let me look up my answer, which I worked on the other just before starting recording, because I don't remember for sure. I sometimes have to look these things up myself. Let's look. So here's project. Okay. Yep. And here's methods. Yeah. Just as I thought. Just as I thought. So the return type goes before the data record and then the name of the thing. So that's what I was thinking I was correct, but I just couldn't quite remember. So anyway, let's do it like this. Void. Okay. Data record. And void. Okay. There you go. Data record. So of course, this is also how your book does separating, creates classes. It separates the method implementation and the method declaration. And this is a standard way that it's done in industry and out in the real world. The reason why is because it allows us to separate concerns across files. This, excuse me, this is just a blueprint of what we want our class to be like, right? So it's very well organized. This is another file where we actually do the bulk of the coding, right? And of course, main.cpp is a separate part of the program. So just like we wanted to use .h files to begin with, so that one programmer could be in charge of the class and another could be in charge of main. Now we can have a programmer, or we can have a programmer that sets the blue type of the blueprint of the class inside data record.h. No one touches this except for that one programmer. Then we can give access to this to a team of programmers who are actually going to implement the methods of that class. And we can give this to a different team of programmers. And so these guys are in charge of the class and these guys are in charge of main, and they cannot mess with each other's code. And so that's a way of organizing our coding, our collective coding efforts, and keeping each other from stepping on each other's feet. And this is the way we're going to do it in class from now on, as I said earlier. Okay. Now, this is pretty simple. Once you get the basic idea, everything should be golden. So I'm going to save this. All right. Now, here's the tricky part that pops up, because we now have two .cpp files. And if I hit compile, I get some errors. And this error says undefined reference to data record, undefined reference to data record, blah, 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 5 errors. It doesn't know how to do this, okay? Now, what we need to do is we need to compile this code differently now, since we have multiple CPP files, okay? First, we need to compile this file that references data record into what's called an object file. And I can do that by typing it in on the terminal, on the command line, right? And that's totally doable. And certainly what I'm about to show you, the way we're going to do it is not the only way to do it. We could do it manually if you wanted to. But you can see how there would be a lot of overhead for that and a lot of room for error. And really, we want the IDE to help us take care of this sort of detail. So I could compile this into an object file, and then compile this into a separate object file, and then tell the compiler to compile those two object files into an executable. That is not by default what happens when I push this button on this file. This button doesn't even know. There's no way for the IDE hasn't been told, so there's no way for it to know that this and this are related in any way, right? You can have a bunch of files open, and if you hit this button, or this button, as many of you like to do, on main.cpp, it just tries to compile what's here. And this thing, excuse me again, this thing links only to this thing, and this thing is missing its things. It's missing its method implementations. They're over here, and we don't know about that. So we need a way to tell the integrated development environment, right? We need a way to tell the integrated development environment that all three of these files need to be compiled together. And the way to do that in most IDEs is an entity called a project. So I'm going to show you how to do that for code blocks, which I have right here. The process is almost identical, right? Things are obvious, the menus are different and things are laid out in different places, but the process is almost identical for Dev C++. And indeed, any IDE that you use will have a similar process. And depending on the IDE you're using, you may have to look up some documentation for how they support projects, okay? So this is an entity called a project. Inside the IDE, set up an organization of files that allows the IDE to know that it needs to compile multiple CPP files together. So we're going to do this. This is how we do it if we already have the files ready and we need to put them into a project. So we're going to do File, New, Project. And so my IDE can compile to a lot of different types of programs. All the programs we're going to be doing in this class are console applications. So I'm going to select console application, click go. Okay, yeah, it's just giving me some information. Click next. This will be using the C++ language. Click next. All right, and I'm going to choose this file, which is my working folder. This is where I have my 3 files. So this is where I'm going to put my project file. Okay, so I'm going to open this up. And I'm going to name this project first project. You can name your project whatever you want. Name it something that makes sense. Next. Yep. Leave debug on. Leave release on. All this is fine. We're just going to leave this unchanged. These are useful settings that you can manipulate, but they're not going to be useful for us in this class. And we click finish. Okay. So let's go over here, and I'm going to open up that file. And let's see what that looks like. So here we are, 255. Here's in-class solutions. Here's project lecture. Here's my working folder. Okay. And these are the files I created: data record, main.cpp, methods.cpp. And you can see this main.o. When I tried to compile main.cpp, it created this main.o, and then it crashed. So I'm going to get rid of this because this is extraneous. Okay. So here are my 3 files. Now I like to do this. I like to go ahead and put these 3 files into my first project. Okay, but before I do that, let's open this folder up. And you'll see that there's a .cbp file. This is a file that was created by Code Blocks. It is a Code Blocks project file, CBP. Never send me the CBP file. What's in here is just a text file. Let's see if I can open it up. Yeah, so as you can see, what's in here is just a text file with some XML that are settings that let the IDE know about all these other files that are already in here. So if you send me this, I won't be able to compile it. I won't be able to use it. It will not contain your code. Obviously, other IDEs will have other ways of handling this information, but you should still never send me just this file, right? That is the file that is the organizational structure of the project you just created. All right, wait, what's this main.cpp that's here? Well, to go over here, so let's go back over here, and over here, once we created this projects tab opened up, and you can see here's first project, and then drop down, here's sources. Here's that file main.cpp. When I create a project in Code Blocks by default, and it's similar for other IDEs, when I create a project by default, main.cpp is automatically given to me, okay, to start with. Well, that's not a file that I want. So I'm going to close this, and I'm going to right-click on main.cpp, and I'm going to say remove this file from the project. Okay, so now there are no source files. There's no code files in this project. Okay. Yeah, but look, main.cpp is still here inside this folder, so I'm going to delete it just to get rid of it. Okay, go up a level. Here are my files. Let's cut these and paste them inside of our project folder. Does that mean that they're here? Okay, does that mean that they're here automatically? No, I don't see them. So let's add files. Okay, I'm inside my project folder, and here are the 3 files that I want to add. So we'll open all those. Yep. Okay, and I get this drop-down window again with sources and headers. So my sources folder inside the project has main.cpp in it. Okay, save all these. And we'll close, close, close. Here's main.cpp. Okay, here's methods.cpp. This is the file that has my method implementations in it. And here's data record.h. Okay, let's try and compile this. All right, great. It compiled without errors and out warnings, but let's look at what actually happened on the inside. You can see G++ is the name of the compiler, and it compiled main.cpp into an object file. And then it took G++ and it compiled methods.cpp into an object file called methods.o. And then it took the compiler and it took main.o and methods.o and compiled them together, right? It did that automatically without us having to do it. And so when we run this program, there's no output in this program, but it runs without error, right? And that's how you're going to have to do it if you need to separate into, you need to separate your method declarations from their implementations. Create a new CPP file, drop your implementations in there, make sure you tell the compiler that each of these is from whichever class it's from. And then no matter which one of these you have focus on, right, this button no longer compiles just one file. It compiles the entire project, okay? So I can be over here and I can compile it. All right, oh, sorry, I ran it rather than compile it, but let's prove I can compile it actually. Yep, target is up to date. Let's make a meaningless change to this .h file. Here's another good thing about projects. If I compile this, oh look, it automatically saved data record.h. It automatically saves all the changes that you make to all the project files when you hit the compile button. That saves us so much headache. It's great. Also, I did not have to be looking at only this file with the main in it. I could be looking at any of these files. Any of them could be open or they could all be closed, and I can still compile this project without error. Okay, so let's go ahead and open all these back up. And that's it. That's the trick. I'm going to want you to start using projects inside your IDE because I'm going to want you to separate out your implementation, your method implementation from your method declaration, which is going to mean that you're going to have multiple CPP files, and the best, easiest way to solve that is with projects. Okay, so let's open this back up, and we'll go back over here and look and see what's inside this folder. So here's 255, here's this, and here's this. This is where we've been working. Okay, so here's my first project. That's all the things that are inside my project. You can see that here's my data record.h, here's my main.cpp, here's my methods.cpp. These are files which were created automatically by the IDE to support using a project. There's some object files in here for debugging purposes, so main.o and method.o get stored in here. And the bin, which stands for binary, we're on debug setting. Here's the actual code that gets run when I execute your program. Now, this structure might be different. The structure might be different depending on what IDE you're using. And when you submit your stuff to me, what really matters to me is that I'm able to see the code itself, and I can compile that code together. So as before, so these are my original files, right? So we can actually get rid of these. So as before, I want you to right click, just go to the project so that you're looking at the project folder when you get ready to submit, when you're done. Right click, compress, create a zip file, send me this file, okay? Because if you send me your entire project folder, right, then we can be sure, if you've done it correctly, that your code is in here. Other things may be in here too, that's fine. I want you to zip it all up, zip up the entire project folder and send it to me when you submit things for grading. Okay? We'll have time to go over this in class. in the process of making new code in class, doing exercise examples in class. I won't spend any more time talking about the specifics of projects and separating implementation from declaration. But when I do in-class exercises, we will be using those procedures. And so at that time, if you have questions about it, you can ask me in class. Or if you have questions about this, you can ask me outside of class or in office hours or whenever. Okay, I hope you're well, and I'll see you in class.